Today we talk about glass nanoparticles and glass nanofibers. What kind of nanoparticles of glass is bioactive glass nanoparticles? The bioactive glass has dimension between 20 nanometers. This kind of glass has a high specific area, just like more surface energy. This glass is widely used to repair and replace of bound tissues. In this case, when a bioactive glass is implanted, they dissolve gradually and the released ions promote the growth of a layer of carbonate hydroxyapatite of the surface. Okay, to obtain this nanoparticle, one process is the henge. In the first step, the oxides are fused at a temperature higher than 1300 degrees Celsius, followed by a cooling. In this part, it's obtained that a fluid that contains a high length, so the next step is made to obtain the nanoparticles. In the second step, the organometallic precursors are mixed and head up to a flame reactor, and the nanoparticles are collected in a filter over the flame, and in this method the cooling allows the formation of amorphous temperature of 20 to 80 nanometers, and finally a bioactive glass is obtained that has the composition of 45 of silicon oxide, 24.5 of sodium oxide, and as well as of calcium oxide and 6 of phosphor oxide. Other for to obtain bioactive is the salt hell. This method is more used because need temperature not so high than the other method. It is based on hydrolysis, which is the process of breaking, in this case, the enlace between silicon and oxygen when at water. And condensation is the reserve process where two molecules add water. This process is carried out for silicon precursor, in this case tetraethyl orthosilicate. Hydrolysis and condensation produce the formation of primary colloidal nanoparticles. In this image, two strategies are evidenced. In the first, ammonium hydroxide and calcium nitride are used, and through washing annealing the nanoparticles are obtained. The second strategy that is more effective is that a cyclic process occurs, which processes the complete reaction and leads to more crystalline particles. Those particles are carried to the washing annealing process and the nanoparticles are obtained. Okay, in the nanofibers, a technique for obtaining them is the laser spinning. In this technique, ultra-long nanofibers are produced. To obtain these fibers, a laser is used to melt a small volume of the precursor material at high temperature while using a gas jet supersonic to quickly lengthen the molded material. The nanofiber generate high-grade application in the field of catalysis or high refractory materials. Other technique to obtain nanofibers is the electrospinning. Where one-dimension nanofibers can be manufactured as nanofiber on an industrial scale with diameters, composition, and control morphologies, and has wide application in biomedicine and filtration technology. with these tables, you can see the reagents that you can use to obtain nanoparticles and nanofibers. According to the application, one of the most important applications is the bone regeneration. Recent research has shown that bioactive glass nanoparticles with copper can be used for this purpose of synthesis of an ultrasound-assisted vessel, preparing crystal of silicon oxide, calcium oxide, doping with copper. An optical composition is a possible that you can use other composition, but it's important the percent of copper because if use a high composition, a high percentage of copper, the properties of the nanoparticles change, and for example the surface area decrease, and no, these are good strategies for the use. For that, one possibility is 2% of copper and 13 calcium and 85% of silicon, and particles are obtained with a dimension between 170 and 200 nanometers. This technique made it possible to obtain monomers, spheroidal particles containing copper that had a highly homogeneous size, a surface area, and uniform mesoporous channels. In addition, the particles had had the property that is antibacterial. Other is the osteoconductivity, that is for guidance of new bonds, stimulate bond osteogenesis for promoting new bond formation, and angiogenesis for inducing vascularization. For that, these nanoparticles is very used in this part of the medicine and have a good advantage. This is the logic to obtain more information about the glass nanoparticles and glass nanofibers. And this is the reference. Thanks for your attention.